Have you ever stopped to think about how a computer actually learns? I mean, really think about it. How does a machine understand something as human as language? How does it know that sci-fi and romance are two different movie genres? It all comes down to solving one massive, fundamental problem.
And that problem is this. How on earth does a machine, a thing that runs on pure logic and numbers, learn from a word, something like the color red, or a concept like high?
Well, the short and simple answer is, it can't. Not directly, anyway. See, at their core, computers are just unbelievably fast calculators. They don't get concepts, they don't get categories, they only get one thing, numbers. And that's the puzzle we have to solve.
And the solution, the hero of this entire story, is the encoder. Just think of it like a universal translator. Its entire job is to take all of our messy, human, word-based data and turn it into the clean, simple numbers that a machine learning model can actually understand and work with.
So, how does this whole translation thing work? Well, let's start with the two most basic tools in the entire toolbox: label encoding and ordinal encoding. These are going to be your first go-to methods.
Okay, first up, we have the label encoder. And honestly, it is about as direct a translation as you can possibly get. It just looks at every unique word you have and slaps a unique number on it. Simple as that.
It's really just a one-to-one swap. The encoder just goes down the list. Red becomes 0. Green becomes 1, blue becomes 2, and so on. Each category gets its own special integer.
So, when would you actually use this? Well, the label encoder is absolutely perfect for your target variable. That's the final thing you're trying to get your model to predict. Like, say you're trying to predict if a customer will buy something, and the answers are yes, no, or maybe. Label encoding is perfect for that.
Now, let's get a little bit smarter with our next tool, the ordinal encoder. At first glance, it looks a lot like the label encoder, but it has one critical, game-changing superpower. It actually understands and preserves a logical order. So here, the numbers aren't just random labels anymore. They actually mean something. Low becomes 0, medium is 1, and high is 2. The machine can now literally see that 2 is greater than 1, meaning high is greater than medium. That's a huge piece of information we just gave it.
This makes it the absolute perfect choice for any feature where the categories have a natural sequence. Things like t-shirt sizes, small, medium, large, or maybe customer satisfaction ratings, from bad all the way up to excellent.
And this right here is the main thing you need to remember. With a label encoder, the number 2 for blue isn't any better or bigger than the number 0 for red. They're just different labels. But with an ordinal encoder, the number 2 for high is mathematically greater than 0 for low. That relationship is everything. Okay, so we've got our basic one-to-one translations down. But what happens if your data doesn't have any order? You don't want the model thinking that blue is somehow better than red just because its number is higher. For that, we need a completely different way of thinking, one-hot encoding.
Yeah, so instead of just swapping one word for one number, the one-hot encoder does something totally different. It actually creates a brand new column in your data for every single category. And then it just uses a simple system of ones and zeros to mark which category is the right one. So instead of getting a single number, the word red becomes a list 100. The best way to think about it is like you have 3 light switches, one for red, one for green, and one for blue. For the category red, you just flip the red switch on and keep the others off. This completely gets rid of any false sense of order between them.
This is your go-to method for what data scientists call nominal features. That's just a fancy way of saying categories that have absolutely no ranking. We're talking about things like country names, types of fruit, car brands. A Ford isn't greater than a Honda, and this method makes sure the model knows that.
All right, so we've got our basic toolkit, but what happens when things get really messy? Like, what if you have a feature with hundreds of different categories? That's when we need to pull out some of the more advanced, specialized tools from the shed.
So first up is the binary encoder. This is a really clever twist on one-hot encoding. It starts by turning categories into numbers, just like before, 0, 1, 2, 3, 4. But then it converts those numbers into binary code. So the number 4 becomes 100 in binary. This means it only needs 3 new columns instead of the 5 a one-hot encoder would have created. It's way more compact.
So, what's its superpower? It's all about efficiency. If you have a feature with a ton of unique categories, what we call high cardinality, a one-hot encoder would create a ridiculous number of new columns. Binary encoding keeps your data much, much smaller and easier to work with.
And for our final tool, we have the target encoder. Now this one is really cool. It doesn't just assign some random number. Instead, it replaces a category with a meaningful number that it calculates from your data. For example, instead of just encoding New York, it might replace it with the average sales amount for all the customers from New York. It's actually encoding the category with info about the very thing you're trying to predict.
Now, this is a seriously powerful technique, but it can also be a little tricky to get right. You'll often see it being used by more seasoned pros, especially in data science competitions. So hey, don't worry if it seems a bit much for now, just focus on mastering those first few we talked about.
Whew! We've covered a whole bunch of different tools, which of course brings us to the most important question of all. How do you actually choose the right one for your project? Okay, so you're sitting there, you've got your data in front of you. Which encoder do you pick? Let's break it down into a super simple guide.
Here's a little cheat sheet. First, just ask yourself, does my data have a natural order, like small, medium, large? If the answer is yes, Ordinal Encoder is your friend. If not, ask the next question, is this the actual thing I'm trying to predict? If it is, a simple label encoder will do the job perfectly. Now, if it's just a regular feature with no order, you're probably going to use a one-hot encoder. But, and this is the key, if that feature has tons of categories, then you should really consider the more efficient binary encoder to keep things from getting out of hand.
At the end of the day, encoding isn't just a technical step. It's about translating human meaning into a language that machines can understand. And honestly, it's just the very first step in preparing our data. So that leaves us with one final thought. Now that we can teach computers to understand words, what other amazing ways can we transform our data to build even smarter, more insightful models?